Hello everybody and welcome. Today I'm going to start a new series. I'm going to start making full video games using MonoGame and C# and the library that we've been working on. So here's kind of where the rubber meets the road. We want to take what we've learned, what we've been working on, and compile it all together into something that is fun to play. Something that is amazing and cool and just enjoyable, and something that other people can play and hopefully get enjoyment out of as well. But this is also, when you start making real games, this is where you really need the persistence and the stamina. You need to take it one step at a time and just enjoy the journey. And every time you make something that works, say the collision detection works, take that as your victory for the day and then move on to the next thing. Really enjoy what you're working on. Every piece, not just the finished project, but enjoy every piece that comes in and makes the game better. But as you go along, really remember it's more about the journey. So, having said that, the game that I'm going to start making is going to be an Asteroids style video game. And we're probably going to have vectorized graphics and collision detection. We got to add sound to this, some kind of menu system. But really, it's kind of a continuation of what we've been working on with the flat game library. So if you need help getting going with MonoGame or getting started with MonoGame, go ahead and take a look at the previous series. At the very beginning we talk about that. It's the MonoGame 2D playlist, and that's where we created the flat game library, which we're going to be using to help us with this project as well. And so you can watch those videos if you haven't already and get an idea of where we're coming from. But I also have the source code here available on GitHub, so if you come in here and search for the flat game lib, you should be able to find all of the source code for that if you would like to use that as well. Or if you just want to get familiar with what we've been doing or how this works, it's all right in there. But we will be adding to this library as we go along now. As we're creating this game, we're going to hopefully see holes that we can fill or bugs that we can correct, and just really round out this library with things that will help us in making games. Let's go ahead and get started. I'm going to create a new project. This is going to be a MonoGame cross-platform desktop application. I'm going to call this Flat Asteroids. Hit create there. And I don't intend this to be a clone of Asteroids. Maybe similar, and maybe having a similar idea of a spaceship flying around, and you're going to be able to change his orientation and apply a force of acceleration in certain directions and that kind of things. We will have projectiles that we'll be able to fire and shoot down the asteroids, and probably other entities as well that we want to, in order to add a challenge maybe to the game. But now that we've created the new MonoGame project, let's go ahead and open up the Game 1 CS in here. I'm just going to start really quickly getting this back up to the way I like things to look. So you can kind of follow along with the changes I'm making. I like to preface everything that belongs to the class with this. I'm going to get rid of all of the comments. I'm not going to use that sprite batch, so we'll get rid of that. Get rid of all of this code and the comment and this. Okay, so I think we're at the basic point here. So let's go ahead and bring in the flat library that we've created. We're going to right click on the solution and we're going to add an existing project. I'm just navigating to the file location on my hard drive and I'm adding the project, and there we go. We have flat library in our solution. The next thing we need to do is now add a reference to the flat library into our flat asteroids project, so then we can use all of the functions and classes that are available. We'll just click that and we'll tell it flat is the one that we want to add in a dependency for, and we'll click OK. Once I've done that, I should be able to start using the namespaces for the flat library. And it looks like they're showing up just fine. So I'm just going to go ahead and bring those in right now, all of those namespaces. And a couple of namespaces up here. I also want to bring in the system namespace. I want the diagnostics, and I also want the collections. Now we're kind of at a blank slate. If we run this, here we are. It's our blank flat asteroids game. It's just basically a flat canvas, and we're good and ready to go. The first thing we want to do is start bringing in all of the helper objects that will get our game up and running. And the first one is the screen. We can create with the screen a render target that has a constant resolution but will stretch to fit whatever display the user has, whether it's the actual full display of their monitor or the window they're currently in. So I've got the screen there. Let's go ahead and create this screen. It wants to pass in a reference to the game class. And the width and the height, I'm just going to pick some numbers here. I'm going to say 1280 by 720 for now. This is subject to change depending on whether that actually works for our game or not. And then we want to, inside our draw, we want to set the screen as the render target. And then right here is where we're going to do all of our game drawing. And then once we've finished the drawing, we'll go ahead and unset the screen. So the render target goes back to the back buffer. And then we're going to present the screen. And the screen presenting function actually needs a reference to the sprite batching class that we created. So we're going to leave that undone right now and bring in a reference to the sprite batcher. And so now that we have that, let's go ahead and create it. And we'll pass in the game, and then we can just pass in the sprites. So that one's all done. And in fact, we should be able to run this and actually see, there we go, and we can see it's being stretched to fit inside this window, but keeping the same aspect ratio. So it looks like it's working just fine. All right, the next thing we need is our shape batching class. This will allow us to draw all the shapes we're going to need. Let's go ahead and initialize that. And let's go ahead and draw something just to test it out, make sure everything's working okay. With the shape batcher, we begin batching, and it wants a camera, so we'll have to come back to that. And then we end batching, and then in between, we draw whatever we want. Let's go ahead and draw a circle just to test it out. It wants an X and a Y position, so I'm just going to say 32, 32. The radius we'll make 64. The number of points we will make 24. Thickness of the line is just going to be 1, and the color will be a light green. Yeah, let's do that. Okay, and now the begin function does want a reference to the camera class, so let's go ahead and create that as well. And then the camera needs the screen. That looks all good. So now we have the camera ready to go. Let's go ahead and pass it in. We should see a circle on the screen now. Okay, perfect. That looks really good, actually. I do want to change this background to black. And then I want to bring in the keyboard and mouse input singletons. So inside the flat library, we have something called the flat keyboard. But these are singletons, and so we have to actually get a reference to that singleton object. And so I'm just going to get a reference to the flat keyboard instance. And then we need to update the keyboard every time the update function is called. And same thing for the flat mouse. That'll be our mouse interface, and it's a singleton, so we need to get an instance of that object. And then we need to update the mouse. So now we should be able to use the mouse and keyboard. Let's go ahead and check that. I'm going to actually now zoom in with the camera. So I'm going to check with the keyboard. I'm going to find out if the A button is clicked. And if it is, I want to tell the camera to increment the zoom. So that'll zoom in on our game. If the keyboard is clicked Z, then let's just tell the camera we want to decrement the zoom, so we want to zoom out. And so we can run that and just check to see if that works. Alright, yeah, that looks good. So zooming is fine. Now I also want to make this window quite a bit bigger. Let's go back up here to the initialization function. I want to make the window about 80% the size of whatever the screen is that the user is currently using. So when the game starts up, the initial size of the window is going to be 80% of whatever their screen is or their monitor. And we can get that by getting the display mode. And the display mode I'm going to call DM. That comes through the graphics device. We can just call display mode there. Once we have that, we're now going to tell the graphics that we would prefer that the back buffer width is 80% of whatever the display mode width is. So I'm going to take the display mode width, which is the current, and multiply it by 0.8, which will give us 80%. And then this back buffer width is looking for an integer at the end, so we need to cast this back into an integer. And then we want to do the same thing for the height. And that'll be 80% of the current display height. Once we've done this, it won't actually apply this width and height to the back buffer until we call a function. We need to tell the graphics that we want to apply the changes. we have to apply changes before any of this takes effect unless we are in the game one constructor. And if you look up here, we create the graphics object, graphics device manager object. I'm going to change one more thing up here and just make sure we are synchronizing with the vertical retrace. I'm going to set that to true. And here, I don't need to tell graphics that I want to apply changes. After the constructor is all done, it applies all the changes that we made inside the constructor. But outside the constructor, we have to call this graphics apply changes to make sure that gets applied. And I'm going to add one more field here. I want the fixed time step to be true. Now I think it's already true to start, but we'll go ahead and explicitly tell the program we want the fixed time step to be true. Let's go ahead and see if our window is the right size now. Okay, there we go. So the back buffer window is a lot larger and we have our game. We can still zoom in on our circle. That's the starting point for our game. This is where we really get to test our mettle, I guess, is when we start making real games. I'm a big proponent of actually making games instead of making engines per se, although I do really enjoy the engine making part of games. If you're making a real game and then making an engine along the way to go with it, you can see what is really needed in an engine for the type of game you're going to be making, or in the library you're going to be making. Before we finish, let's do one more thing. Let's go ahead and actually make the polygon that will be our ship. If you've been following along with the flat library creation, we actually kind of made a polygon that looks like a ship. I'm going to do that almost exact same thing as the polygon for our ship. Let's go back to our drawing program here and let's draw what we want it to look like. Here is the y-axis and here is the x-axis. Let's go ahead and draw some points. The top of the ship is actually going to be on the right because the 0 rotation actually starts on the x's 1 and y 0. So this is where, if rotation is 0, this is where the point would end up over on this side. So this will be the top of the ship. And then down here, I'm going to have another point that will be the bottom right. This up here will be the bottom left of the ship. And then somewhere in here we'll have a couple of points to just make it look fun and interesting. Let's draw these points just so you can see what it looks like. There we go. So this is by no means exactly to scale, but let's put some numbers in here just so we can get an idea of what I'd like it to look like. This will be the first vertex, 0 vertex, 1, 2, 3, and 4. Wherever the origin is, that's going to be your center of rotation for your object. Okay, whatever object you create. If I made the spaceship over here, right, and it looks something like this, now it's going to rotate around this point. You'll see this point will be stationary, but everything else will rotate around in a circle like this. And so it end up looking something more like this when it rotates. But this is not what we want, right? For our spaceship, we actually want it to rotate about the center. And so if this is the unrotated version, okay, and let's just pretend I drew that so it was centered at the origin. If we were to rotate left now, it would look like this. And that's what we want. We want all the points to be rotating around the center, just like that. There's our 5 vertices. Let's go ahead and define where they're going to actually exist in space. And remember, now that we're creating a real, tangible video game, we want everything to be in real measurements. So we're going to start doing everything in meters and meters per second. I'm using the metric system. Let's go ahead and define how many meters this is going to be. So from the center point here, I'm going to go to the right 10 meters. So this point will be 10 on the x. And the y is just going to stay here on the 0, so that'll be 0. Down over here, we're going to now go 10 meters to the left, so that'll be a -10. And then we want to go 10 meters down, which will now give us a -10 here. And let's go ahead and go up to this one now. So the x is going to be the same. We're going to go to a -10 meters, and then, but on the y, we now have to go up 10 meters, so let's put a 10 there. Now these, let's just go ahead and pick some numbers that might be good for these. On the x, we need to go left a little ways. Let's just pick a -6 and see what that turns out to be. And then down here will be -3 meters. At this point, on the x will be the same, so -6. But the y will be the inverse, will just be a +3 meters. We have all our points for our spaceship, and let's go back and create the vertices. So the vertices are simply going to be vector2 structures. So we'll have an x and a y for each one. And we are just going to call this vertices for now. And this is going to be very temporary because we're going to be moving this into a separate class eventually. But let's just call it vertices. Let's define our vertices. We know we have 5 vertices. And let's just explicitly tell it what each vertex is going to look like. So we know the first one was over to the right 10, and then the y was 0. We'll just copy this 5 times. So the second vertex was -10, -10, and then the 5th vertex was -10, 10. So let's go ahead and put those 2 in there. So this one was -10. -10, and then the last one was a -10 on the x, but a +10 on the y. And then the middle ones, the third one was a -6, -3. So -6 and -3, and then this one, the -6 was the same, but then the y was the +3 inverse. There's our vertices. Let's go ahead and see if we can actually draw that now that we've defined them. We'll get rid of this circle, and we're going to tell the shapes that we now want to draw a polygon. Let's pass in the vertices. We don't have a transform yet. Skip that and go on to thickness. Thickness will just be 1, and that's the line thickness. And then the color, we can do a sea green. So now we need to define the transform. For now, we'll just make that a member of this class. And again, we'll be breaking this out later to be a part of a general entity class that'll take care of all this for us. But for now, we just want to test out our vertices and our polygon drawing, make sure everything looks good, maybe get an idea of what our player ship might look like. We have the flat transform, and the flat transform is a struct that we created inside our game library to make two-dimensional transformations nice and easy for us. We'll just call this transform. The transform is not going to do anything special. This will just be a new transform. The position is just going to be the origin, so let's just put it 0, 0. We're going to have 0 angle of rotation and ×1 scale, which will just keep it the same size. So this is kind of like, for a matrix, this would just be like the identity matrix. Let's go ahead and pass that in and see how that looks. Okay, so there we are. Let's zoom in. And I actually like the way all those vertex positions turned out. So I think I'm going to keep it there for now. I may move this line just a little bit back over here. In fact, yeah, let's give that a try. I want to move that bottom part line of the spaceship a little bit to the right, so we'll make this a -5, and let's just see how that looks. Yeah, I think I like that better. Yeah, let's keep that. I'm going to keep it like that, subject to change. And let's modify the transform so we have just a little bit of position change. So I'm going to make this a -32 here and a -32 here. Actually, this makes it a -32, +32. So it's going to move it back to the left and up a little bit. And rotation, let's go ahead and change the rotation a little bit. So we'll call the math helper, and let's just say pi/4. Okay, so pi/4 is going to be it's going to be a 45-degree angle. And so let's just make sure that all of our transforms are working just fine. All right, there we go. And as I zoom in, you can see it's been moved up a little bit and over to the left a little bit and rotated. Okay, so there we go. That's as far as I wanted to get in this video. Next time, we're going to start talking about entities.